In this video, we're going to be finding volume using cylindrical shells and integration by parts. Use the method of cylindrical shells to find the volume generated by rotating the region bounded by the curves y equals 6e to the x, y equals 6e to the negative x, and x equals 1 about the y-axis. So as always, the first thing we want to do is to graph these equations, these curves, which I've done in Desmos. And so the area, the region that we're going to be rotating about the y-axis is bordered on the top by the red curve, which is 6e to the x. On the bottom by this blue curve, which is 6e to the negative x. And then on the right, by the line x equals 1, and the two curves intersect at x equals 0 as well. So the bounds of integration will be along the x-axis from 0 to 1. So I'm going to go back to the PowerPoint, and let's draw a small representative curve here. So we have the one curve, it's going to go something like this. The other one is doing something like this. And then we have x equals 1. So there's 1 and 0, and this is our region. To draw a representative rectangle in this region, the rectangle is going to be vertical, because remember, using cylindrical shells, the rectangle is always parallel to the axis of rotation, which is the y-axis. So we're rotating it about the y-axis here. And so the integration is along the axis that is the width of the rectangle. So we're going to be integrating with respect to x. All right, so the integral itself is going to be set up according to our cylindrical shells formula, which is volume is equal to the integral from a to b, 2 pi x times f of x dx. And so when using this method, of course, it's important to remember what x and f of x represent. X represents the radius, or in other words, the distance that our given rectangle is from the axis of rotation. So the axis of rotation being the y-axis, then this distance here would represent the radius of our cylindrical shell. And so that's simply the distance x. So x represents the radius. F of x represents the height of the rectangle. Well, the height of the rectangle, the top of the rectangle is at the curve 6e to the x, and the bottom of it is at 6e to the negative x. So in actuality, f of x is going to be the difference between those two curves. So let's get it set up. So the volume is going to be 2 pi. The integral will be from 0 to 1, x, and then f of x is going to be 6e to the x minus 6e to the negative x dx. That's the basic integral. We now need to multiply through the x. So volume is 2 pi times the integral of x, let's put 6 out here, 6x e to the x minus 6x e to the negative x dx. Well, it should become apparent at this point in time that we're going to have to use integration by parts to integrate this. So I'm going to break this into two separate integration problems. Volume is equal to 2 pi times the integral from 0 to 1 of 6x e to the x dx minus 2 pi times the integral from 0 to 1 of 6x e to the negative x dx. And so we have to do integration by parts on each one of these. So cleaning it up a little bit, let's take the 6's and bring the 6's out. So volume is going to be equal to 12 pi times the integral from 0 to 1 x e to the x dx minus, again, 12 pi times the integral from 0 to 1 of x e to the negative x dx. So on the next slide, we'll integrate each one of these. And so on our first integral, where we have the volume is equal to 12 pi times the integral from 0 to 1 of x e to the x dx. Let's let u be equal to x. So du is going to be 1 dx. dv will be equal to e to the x. And so v is going to be also equal to e to the x. And I should have a dx up there. So our formula here, volume is equal to 12 pi times u times v. Once again, our formula for integration by parts is uv minus the integral of v du. So u times v is x e to the x minus the integral of v du. Well, that's simply e to the x dx. Well, that's easy to integrate. The antiderivative of e to the x is simply e to the x. So the volume is 12 pi times x e to the x minus e to the x. Now the second integral was similar to that. Volume is equal to 12 pi times the integral from 0 to 1 of x e to the negative x dx. Likewise, u is equal to x, du is dx, dv is equal to e to the negative x dx, and so v is going to be equal to negative e to the negative x. So volume is equal to 12 pi, and so we're going to have u times v, which is a negative x e to the negative x, minus the integral of v du, which would be, again, negative e to the negative x dx. And so let's take care of some of these negatives here. So 12 pi times negative x e to the negative x plus the integral of e to the negative x dx. And then finally, integrating e to the negative x, we have the volume is 12 pi times negative x e to the negative x minus e to the negative x. Now we need to evaluate both of those at the bounds of integration, which I will do on the next slide. So we'll start with the first one up here, which is 12 pi x e to the x minus e to the negative x. So we'll actually put all those together. So the volume was equal to 12 pi, and so we had x e to the x minus e to the x, and we had then minus 12 pi negative x e to the negative x minus e to the negative x. So that's kind of putting the whole thing together. And of course, we could factor out the minus 12 pi there as well. Okay, now we are evaluating all of this from 0 to 1. And so this is the part that gets to be a little time consuming. So volume is 12 pi times 1 times e to the 1 minus e to the 1 minus 12 pi times negative 1 e to the negative 1 minus e to the negative 1. And so let's simplify this. Volume is equal to 12 pi. And so this becomes e to the 1 minus e to the 1 is 0 minus 12 pi minus, then this will be minus 1 over e minus another 1 over e. All right, so this all becomes 0. So this part of the volume is negative 12 pi times negative 1 over e minus negative 1 over e, which is a minus 2 over e, which I could simplify that a little bit more, which is negative 12 pi times negative 2 over e. All right, now we have to evaluate it all at 0. So that's the second part. So we have minus, this was all just evaluating it at 1. All of this was just f of b. And now I'm going to go through this up here. And so we're going to have minus 12 pi times 0. So that whole thing is 0 times e to the 0 minus e to the 0 minus 12 pi negative 0 e to the negative 0 minus e to the negative 0. So we got lots of zeros here. Negative 12 pi. This is all 0 minus 1. Minus 12 pi, and so this becomes 0, and e to the negative 0 is a minus 1. So minus 1, this becomes 12 pi, and this becomes plus 12 pi. So this is 24 pi. Okay, so we have this part up here, it's got to come down, negative 12 pi times negative 2 over e plus 24 pi. And so multiplying the numerators, we're going to end up with 24 pi over e over here. Negative 12 times the negative 2 is 24 pi over e. And this part actually here is going to end up being 0. So this ends up being 24 pi over e. I think I made a sign error in here somewhere. So this was a, should have ended up being a 0. And so the answer is going to be 24 pi over e. All right, that is this video.